Chemistry book with all my things that we got these guys. Do you have another like papers of what we had so far? Thank you.
Okay, folks, we're going to go ahead and get started. Just a little bit of an overview of what is coming and about where I expect the test to go off. Today, we are going to continue with our discussion of ionic compounds. We're going to be taking the formulas of ionic compounds and converting it into the names of ionic compounds. So we're going to take the names of ionic compounds and convert them into the formulas of ionic compounds. On Friday, we will start talking about covalent molecules. Specifically, we will talk about 3 types of covalent molecules that are essentially a matter of memorizing, though I will do my best to help you learn how to memorize them like I did with naming. On Monday, we'll talk about binary covalent molecules. And then on Wednesday, we're gonna talk about, acids. And I don't know whether that'll continue on through Friday or not. But sometime around Friday of next week and the Monday of the following week, we'll start learning to write the molar mass of compounds. And after I finish molar mass of compounds, that is where this exam will end, which I believe will be it'll either be the Monday before or the Friday before your exam on the following Friday. So it'll give you most of a week to study. And then after the exam, we're going to hit heavy into reactions, and we're going to talk about balancing chemical reactions, and we're going to start doing some stoichiometry of balanced chemical equations. And so that is where we're headed for the rest of the semester. Any questions? By the way, happy mold day. You're going to learn what mold, if you don't know what mold day is, you're going to learn what mold day is around the 10th of the month. If not, no, around the 1st of the month, roughly. So you'll be learning what mold day is soon, if you don't already know. No, it's a chemistry thing. Okay. So again, today it's going to be taking and learning to write the formulas of ionic compounds given the names, and learning to write the names of ionic compounds given the formulas. I am going to branch into more and more of the polyatomics that you are to learn. In other words, I've been focused on the 8s for the most part. Well, we're going to branch into some more that you will need to know. Okay. So when you're given the name, you translate, you cross, drop, and multiply. So that's what we're going to do is we're going to translate, we're going to cross, drop, and multiply. What I see here is I have 10 and I have the Roman numeral 2. What is the Roman numeral 2 telling me? That the charge on the 10 is a 2 plus. And 10 just happens to be SN. Now, what does the ATE tell me? That it's a polyatomic ion. Now, unfortunately, this one isn't one that you can use what I was showing you. It's one you're just going to have to know. And this one is C2H3O2 minus. If you're looking at your list of ions, it's going to be crammed in with carbon. All the carbons I put together, and it'll be in that grouping. Now we're going to take the numerical portion of the charge and we're going to cross and drop it onto the other ion. When a number is not shown, that means it's a 1. And so we're going to take and cross and drop that on the opposite ion. So on our 10, we're going to drop a 1. And on our acetate, we're dropping a 2. Because we are dropping a number greater than 1 onto the acetate, we put the acetate in parentheses with the number outside. Now, typically, if there's only one of an element, we do not write the 1. So you're typically going to see this written as SN C2H3O2 2. Yes.
Is that a question?
Yes.
Two of them, same name.
There's 2 of them, but go ahead. I'm sorry.
how would I distinguish between those acetate to two?
They're the exact same. If you add up the elements in the other one, you'll see there's 2 carbon, 3 hydrogen, and 2 oxygen. It comes out to be the same. It's just different ways of writing it. Okay, gallium bromide. Gallium is in group 13. What charge does this gallium have? Do we know? It's a +3. Gallium is always a +3. The IDE typically means what? What type of anion? Huh? It's an anion of an element. So bromine, what charge would bromine typically have? It is element number 35 if you're looking at the periodic table. -1, why? Because it's in group 17. So we cross the number and drop it on the opposing ion. So on the gallium, we're dropping a 1, which we don't tend to write. And on the bromine, we're dropping a 3. So the formula for gallium bromide would be GaBr3. Now, when I get to the formulas, and I got to come up with the name, the first thing I'm going to ask myself is what type of metal do I have? Is it a Roman numeral metal or not a Roman numeral metal, basically? Do I need a Roman numeral or do I not need a Roman numeral? Fe is element 26. Does it need a Roman numeral or does it not need a Roman numeral? It's going to need a Roman numeral. What about element number 55, cesium? Does it need a Roman numeral or does it not need a Roman numeral? Now, why did I do that? Because the type that do not need a Roman numeral are real easy. You name the metal, you name the anion, and that is all there is to it. So that right-hand one is simply cesium sulfate. The other one I needed a Roman numeral for. So you're going to have to figure out what that Roman numeral is. And we do that using that equation that I gave you on Monday. We have 1 iron. We don't know what the Roman numeral should be. In other words, we don't know what its charge is. But you should know the charge of every single anion. All the anions' charges are set in stone. Now, this one's a special one of the polyatomics. It's one of the few polyatomics that end in IDE. Does anybody know what it is? It's hydroxide. And what charge does it carry? A -1. So we have 1 iron times Y plus we have 3 hydroxides times a -1, and that all has to equal 0. Y minus 3 equals 0. So y equals 3. Once you know what the Roman numerals should be, you are then to write it. So it's iron 3, and then the anion is hydroxide. Let me come up with some more to work with. What I'm going to do is I am going to put several on the board. And then we're going to go to town. I want you to work through these, and then I'll go over the answers.
they're not listing on there. Because these were your. These are the ones that have a shortage. These have a shortage. No.
What questions have you come up with thus far? Yes.
Can you go over CO with us?
CO, the CO's carbonate, the one I haven't done yet?
Yeah.
Okay, yeah, I haven't done that one because I didn't want to scoot up yet. So this one would be okay, so the one that I was asked about was the cobalt carbonate one. And the fact is you have to do what you have to make the equation to get it right. Cobalt, there's only one. We know we're going to need a Roman numeral, so it's Y. Carbonate is a -2 charge, of which we have two of them. So we have 1Y plus we have 2 times the -2, and that has to equal 0. So Y minus 4 equals 0. Y had to equal 4. So it'd be cobalt 4 carbonate. Did that answer your question on the cobalt?
I'm still confused.
Okay. Let's start with cobalt. Just ask, and I'm trying to figure out where I'm going to try to get through some of the confusion. Cobalt is element number 27. Since it is not one of those that you had to memorize, you needed a Roman numeral. You're always going to know the charge on the anion. And so it just happened to be that one of the anions you're supposed to know is carbonate. It is in period 2, so the 8's going to have 3 of them. And it just happens to have a -2 charge. So the CO3 has a -2 charge with it. The fact that there is, so we had to figure out the Roman numeral on the cobalt, which we made as a Y. There's one of those. There are 2 carbonates. So basically when we're saying how many there is of an anion, we're saying how many of what's inside. How many are there of what's inside? There's 2 of what's inside, which is carbonate, which has a -2 charge. So we set up our equation 1 times Y, 2 times the -2. and we set that equal to 0, and that's where this equation comes from. So y ultimately equals 4, so the charge on that carbonate is a 4 plus charge, and so the total is 4 carbonate. Other ones. And the last one, which I did not have room to put up. Would simply be silver chloride. Trying to keep with the same coating. So you'll notice in all of these cases, one of the first things I did was I figured out, okay, one challenge, probably the biggest challenge, is to know your polyatomic ions. If you don't have your polyatomic ions memorized, that's going to cut out 2/3 of the questions, most likely. So you have to have your polyatomics down. Second challenge. You will be given a periodic table that has the names of the elements. But if you have not familiarized yourself with the periodic table, meaning if you have not done enough of these problems where you can go, okay, it's a metal I don't know, so let me look in this region here. Or it's a non-metal, so let me look over in this region. If you haven't gotten it down to where you can at least say what region it's in, it's going to slow you down, because I've used elements all the way up to lead, element 82. It's going to take you a long time to read 82 elements. So challenge number 2 is knowing your periodic table. I don't make you memorize it, but you got to know it. In the fact that you at least need to know what region of the periodic table to look at. Challenge number 3 is figuring out which of these needs a Roman numeral and which one does not. The ones that don't, if you met challenge number 1, you've already got you got it made, because the ones that don't need a Roman numeral, you name the metal, you name the anion. That's it. And challenge number 4 is being able to figure out what charge is on that metal for the ones that need a Roman numeral, which you're always going to develop that type of an equation. So, for example, platinum perchlorate needed a Roman numeral. I had 1 platinum times Y. Perchlorate is a -1 charge. So 1 times Y plus 2 times the -1 is equal to 0. Y minus 2 equals 0. Y equal 2, and hence the reason for the Roman numerals. Yttrium-3 hypobromite. There's 1 yttrium. I don't know its charge. Hypobromite is BRO, and it has a -1 charge. 1 times Y plus 3 times the -1 is equal to 0. Or y minus 3 equals 0, so y equals 3. And hence the Roman numeral. Mercury. I know that it needs a Roman numeral. There's 1 mercury times y, and there are 2 nitrates. Nitrate is a -1 charge. That's one of our polyatomics. 1 times y plus 2 times the -1 is equal to 0, or y minus 2 is equal to 0, so y equal 2. You will see that I'm always using the exact same equation. The manganese, y, because I don't know what its charge is, and oxygen is a -2. 2y, 2 times y, plus 5 times the -2 is equal to 0, or 2y minus 10 equals 0, 2y equals 10, so y equaled 5. I'm always doing the same process if I need to know the Roman numeral. The hard part in knowing the Roman numeral, though, is knowing your polyatomics and knowing your charges on your anions. Said up front, this was a memory-heavy exam. That's why in last week's folder, you have a link to a Quizlet to help you start memorizing your ions. I figured a Quizlet would be good because that way you always have it. Once you know that, I guess you could always bookmark that Quizlet on your phone. And that way, no matter what, you have it and you can study those ions. Because that, or you make your own flashcards out of that long table. That's pretty much your options. Now, to help you figure out how to name, the only sheet I haven't gone over is this sheet. And this sheet outlines how you name the different types of compounds. We've actually only gone through this much of this sheet so far. The rest of it starts Friday. To me, going from the formula to the name is the harder part, as long as you know your ions. Going from name to formula is much easier because it's translate, cross, drop, simplify. So if I go with okay. When you have this, the first thing I note is I have a Roman numeral that is telling me what? 6 for what? The charge on the chromium. The ending IDE tells me what? It's a negative charge on the sulfur. What? How negative? It's a -2 because it's in group 16. You cross the numbers, you drop the numbers. So we got Cr2S6. And then don't forget to simplify by dividing through by the smallest if possible. So it's CrS3. Indium oxide. Indium has what charge? It is element number 49. It's a 3+ charge. Oxide, the IDE tells me what? It's an anion of an element, -2. Cross, drop, and simplify if possible. In this case, it's not possible. Indium oxide is In2O3. Cadmium hydrogen phosphate. Cadmium, what's its charge? It's element number 48. It's 2+. Phosphate, that's the PO4. And because it's in period 3 through 7, it's a 3-, because it has the same charge as its element. But I added the word hydrogen here, and hydrogen carries a +1. So if I have hydrogen phosphate, it's actually HPO4, and then you add the charges, so it's 2-. So cadmium hydrogen phosphate is simply CdHPO4. Ruthenium 3 hydroxide. Ruthenium, I'm telling you what the charge is. It's a 3+. Hydroxide is one of the only 2 I'm going to make you memorize that are not, there's 3 of them that are ides that aren't elements. Hydroxide, cyanide, and peroxide. Hydroxide is one of the few ides that is not an element. Its formula is OH-1. So we cross, drop, and simplify. So it'd be ruthenium, open parentheses, OH, close parentheses, 3. Practice is the only way to get this, folks. That's why you got a huge practice set for naming and formulas of ionic compounds. It takes practice. Any questions? If not, then I will see you on Friday.